talk about spectrum as if it were a thing, and it's not. And that makes this very confusing. When we talk about spectrum, what we're really talking about is sending a signal by oscillating energy bands. And it works something like this. We think about this. You can make energy go up and down like that. We call this frequency modulation if you're moving from one set of frequencies to another set of frequencies. And the peak of how this moves is the modulation of that change, modulation of the frequency of how often this goes up and down. So if I'm doing this very, very fast, that's visible light. We all know light's a wave, it comes at us, it's coming really fast, that's visible light. Slow it down and spread things further apart. That energy is still oscillating very quickly, but it's not light anymore, it's radio waves. Too slow for us to see, the energy is too slow for us to see, but it's way beyond what we can hear with our ears. Slow it down even more. And you get down to sound, which is why we measure these things sometimes in decibels, the same way we do with hearing, but we also refer to this as hertz, up and down measure. Go fast enough and they're megahertz. Go faster, faster, still push it together, it's gigahertz. The more you change how many times the energy is going up and down and being modulated like this, the more information you can put into it, but there are other trade-offs too. So we talk about spectrum as being these allocations of frequency as if they were a thing, when really what we're talking about is sending a signal like a flashlight, but stretching out the waves so that it's a radio wave flashlight and not a visible flashlight. Back in the old days, when we were first learning how to send signals through these modulated energy waves, what we'll call radio waves or frequencies or spectrum, it was very primitive. You basically had a tower, a radio tower, and you had these very primitive receivers, old-timey radio. And because these devices were very primitive, they could really only interpret one signal coming in on those frequencies. If you had a second tower sending a different signal on the same set of frequencies, the device would get confused. And instead of getting language out of the radio box, you got instead static. That kind of static we call interference. The way that we solved this problem early on was to say only one person can operate on that set of frequencies at a time. So when we do that, it means there's only so many people who can operate. We call the government monopolies to operate on these set of frequencies licenses. So when we did it this way, we only had a very few licenses. That made them very valuable and very scarce. So people learned to think about spectrum not as something like a flashlight where you can have lots of different flashlights going on at the same time, but as something like a loudspeaker where you have one person has the loudspeaker, and if two people try to have the loudspeaker in the room, you can't hear anything and you get all confused. So it's limited and scarce because we said only one person can have the loudspeaker at the time, so that makes that loudspeaker very, very valuable. Open spectrum, sometimes called unlicensed spectrum, because you don't need one of those exclusive licenses to use it. As the technology has advanced over the last 100 years, this dumb radio got to be a smartphone. And the smartphone is actually very good at sorting through the different signals and figuring out, with the computer inside of it, how to ignore the signals it doesn't want, how to interpret the signals it does want. And we've also made these transmitters a lot smarter so that they can talk to each other and say, hey, you're sending these data packets. That's not one loud continuous stream. That's like little broken up stream. Well, you know what? We're smart. We talk to each other. I can send little broken up stream also, and we will fit between the gaps. We call that spectrum reuse, where you have the same set of spectrum, devices or different transmitters are using that shared set of spectrum and reusing that same spectrum multiple times. Now, when you do that, you can say, all right, you know what? I don't need to have just one blowhorn. We can actually say, you know what? Everybody have a conversation. Y'all are smart, y'all go ahead. Now, there are certain rules on this. We say, okay, everybody has to talk using your inside voice. And we count on people understanding, yeah, I want to talk to you. You guys are having a conversation over there, but that doesn't have anything to do with me. So I'm talking to you, you're talking to me. It's not like the license model where it's like you're all sitting there in the audience and one guy with the microphone is saying, you're all listening to me. We'll do two-way in that I'll point to you when I feel like it and you'll be able to ask me a question, but I'm the one guy with the microphone and microphones are scarce. Open spectrum is everybody start talking with each other, and if you all feel like getting together in one big conversation, you can do that. That's what makes it so important for civil society, for developing new innovation and eliminating gatekeeper control. Because if you only have one person with the microphone or two people with the microphone, and they're leasing out that microphone or selling the right to ask the questions, i.e. giving you a cell phone subscription, they can charge whatever they want for that right to speak, because you can't speak unless the person with the microphone gives you permission. But if everybody can talk, then you don't need anybody's permission, either to have the conversation you want or to have it with whoever you want. Open spectrum is a relatively new technology. It's about 30 years old, as opposed to this licensed stuff, which is 100 years old. So one of the problems has been trying to move that technology forward. As you might imagine, the people who have the exclusive licenses traditionally are not very happy about letting other people talk in the room without their permission. It's like, hey, I have the microphone, I'm talking to you, you guys will stop that. So we have rules that have made it harder for people to innovate and do things in the open spectrum space. Some of it has to do with keeping it at low power. Some of it has to do with making certain rights of licensees superior to the unlicensed. So it's like, yeah, you all can talk among yourselves until the guy with the microphone starts talking, and then you all have to shut up. So what we are looking to do, and what's important, is first of all, create more opportunities for open spectrum. Allow more open use, even where you have a a licensed use if it doesn't interfere. You know, if y'all are watching the football game and the football game is going on and everybody's cheering and shouting, it's not going to bother everybody else if I kind of lean over and start talking to my friend. Would bother people if I start, you know, using a bullhorn of my own and making it so that nobody can hear or watch the game. So we do still need to have some rules, but we don't have to have rules that say no talking during the football game or no talking louder than a whisper during the football game, because come on, it's a football game. Me talking to my buddies next to me is really not going to bother people who are trying to listen to the fellows on the microphone. So this is where we get to, we need more opportunity to have open spectrum. We need rules that allow the open spectrum and spectrum sharing to share with the licensed spectrum where it's technologically possible and doesn't interfere. There are going to be times when you absolutely have a need for licensed spectrum. Public safety is often cited as the big one where, you know, when somebody's got to make that announcement, the emergency announcement, that has to go through. But even there, we're learning that you can rely a lot on the open spectrum, because sometimes it works better for people to say to each other, hey, I'm passing along a message that there's an emergency, we've got to get out of here, than it is to say the only way to get an emergency message out is one guy with a microphone. So we need more unlicensed spectrum, we need opportunities to find ways to make it work with licensed spectrum without interfering, and we need to not have regulatory processes that slow these down in order to protect the monopolies that these guys with the licenses have come to enjoy. So we talk about next generation spectrum, and we talk about this for both licensed and unlicensed. And what that usually means is we're bringing in a new technological capacity that's going to allow us to do things more and better, or kind of shoot this up to a whole new level. So in mobile, for example, we went from 2G, which was just voice, to 3G, which was better voice but some internet, 4G LTE, which is integrated smartphones today, where you use data and voice, and we're now looking at, for licenses, 5G, next generation spectrum there, where it's going to be big, fat pipe capacity for your cell phones and for wireless. So, you know, now you can get internet, you know, we're talking about going up to potentially gigabit capacity with 5G spectrum. For unlicensed spectrum, for the open spectrum, it means something similar. We're going to do something new. So first generation open spectrum, the stuff that gave us Wi-Fi, was basically one set of rules. The device has to operate at this power and no more. It has to accept this kind of interference, and they've got to all work the same. Even with that, we were able to get a lot done. Next generation Wi-Fi, what we're talking about now for next generation open spectrum, says, you know what, these devices are smarter. We call this cognitive radio or smart radio. They can actually look around and say, you know what, there's more spectrum here because people aren't using it right now. Yeah, there's a guy with a license who has the right to use this exclusively, but he's not using it, so it's kind of a waste to say, I can't operate here because I'm not going to interfere with him. So next generation says, you know what, we're going to empower devices to work on the spectrum that's available when it won't interfere, even if they have to shut off when the licensee shows up. The other thing we're doing with it is finding ways to make this more reliable and get more throughput, make that faster. So we're looking at next generation Wi-Fi that has gigabit capacity as opposed to current Wi-Fi, which has megabit capacity. So all the things we talk about when we're talking about next generation spectrum, bigger, better, faster, more efficient, are all true for both licensed and unlicensed. And there's actually a lot of back and forth in the technologies between the two. A lot of times people think of these as enemies. It's either going to be licensed or unlicensed, but in the last couple of years, as demand for all kinds of spectrum use have skyrocketed, what we're really discovering about next generation spectrum is it's licensed and unlicensed. And they work together with each other, not against each other.